Hi everyone. Finally we're ready to write a program that will involve a simple calculation. So even though this program is simple, there's quite a lot going on and a lot to talk about. So without delay, I will run the program. Okay, this is a typical temperature converter, and I'm being prompted to enter the temperature outside in degrees Fahrenheit. And it so happens that as I'm recording this, it's very cold out, and it's 13 degrees Fahrenheit. I enter that, and the program performs the calculation. 13 degrees Fahrenheit is approximately negative 11 degrees Celsius. Usually when there's a program like this, I'll test it with a value that I know is accurate. For example, 32 degrees Fahrenheit is 0 degrees Celsius. Everyone knows that. So I'll run that through the program and just make sure that I'm getting the expected result. Okay, so this program is working properly. Let's talk about what's going on. Just a quick view of the code. We're going to dissect this line by line. But we really just have a few lines of code, but you can see, there's quite a bit going on. So let's talk about this line by line, what's happening. Okay, the first thing that happens, these are the first two lines of the program. I am being prompted to enter the temperature in degrees Fahrenheit. This is not the first time you've seen text window .write or the write method of the text window. Anytime you want to display something to the user, you'll use text window .write or text window .write line. That is, if we're doing a console application such as this one. There are other ways that, if we use a graphical application, and we'll talk about those later. So whenever I'm displaying something to the user, that's called output, program output, because you're putting it out there for the user to see. Think of it that way. Now, this next line is very important. There are two things going on here. The first thing is, I guess, pretty obvious. We're using the read method to read the user's input. I typed a 13. So text window.read read that 13 and took it into the program. Now, it takes it into the program, and the next thing that happens is very important. Where does it go when the 13 entered the program? Where did it go? We have this word here, tempfar, or tempfare. That's really going to represent the temperature in degrees Fahrenheit. Where did this come from? I made up that name. That is called a variable. Okay? This is a very important concept in programming. Basically, when you create a variable or introduce a variable into your program, like I have in this line, you're reserving a little piece of memory in the computer. And you're putting that value, in this case 13, into that memory location so that you can do something with it. For example, convert it to degrees Celsius in this case. Do something with it, store it, retrieve it later, perform a calculation on it, display it to the user later, whatever. So storing a value in memory in a variable is a very, very common thing to want to do in a program. It's really, at the heart of programming, I would say. So here, looking at our illustration, if you can imagine this, the user types in a value, the temperature in Fahrenheit on the keyboard. In my case, I typed a 13. That 13 came into our program and was stored in a little piece of memory, which we have named tempfare. Now, anytime from here on in the program, if I want to retrieve that value, all I have to do is type the word tempfare. Okay, so the next line in the program is the actual calculation. And this is a very common formula. You can Google, Fahrenheit to Celsius, and you'll see a formula like this. To get the degrees Celsius, we multiply, we first subtract 32 from the degrees Fahrenheit and then multiply the whole thing by 5/9. Basically, we have our temp. We already established that the 13 went into the tempfare variable, and that is in memory. Now, I'm computing the degrees Celsius, and I have to, when I compute the degrees Celsius, I'm going to get a result. In this case, around negative 11. I've got to put that somewhere. Where do you put anything in programming? Into a variable. So I have another variable that I've introduced to the program, which we've called tempcells, and that will store the result of the calculation. Okay? Oh, just one more thing here. We have a lot going on in this equation. We have two variables. We also have some plain numbers, like 5 over 9 and 32. These, when you have just regular numbers in your program, these are called constants. And what do we mean by constant? It means not a variable. A 5 is a 5 is a 5, and it's not going to change during the course of our program. A 32 is a 32, and that's not going to change. That's hard-coded into our program, that number, 32. Variables, on the other hand, they're called variables because those values can change. They can vary. For example, let's say it's summertime, and I'm entering the temperature in degrees Fahrenheit. It may be 100 degrees outside. So, in this case, it's 13 degrees, and that's the value in the variable. But, it doesn't have to be. It can be anything I want to type in. So the variable is the memory location. The value can change. And a constant is really quite the opposite of that. It's just, it's not a variable. It's not going to change. It is what it is, and that's that. So I'd like you to know both terms, the variables versus constants. Constants are really hard-coded, as we say, into your program. Okay, I just threw this line in there. Some students are going to be curious. I'm not that concerned that you use this regularly at this point, but basically the result of that calculation was initially negative 10.555. It's really a long decimal. I'll show you real quick. If I take out this line here and run the program, 13 degrees Fahrenheit. It's actually, very long decimal number. And typically, that's not really great output. Nobody really cares about half of a degree in any case, and certainly you don't want to display a really long decimal like this if you don't have to. So what I did is I used the math.floor method, which would round that value down. So that's why we end up with negative 11. So using math.floor will round a value down. I know you may be thinking that, 10.5 to 11, that's rounding up. Well, we're in negative territory, so it really is rounding down. We get a lesser value as a result. Negative 11 is a lesser value than negative 10.555 and so on. So, and then if you wanted to round a value up, you could use math.ceiling. Okay, the final output. This is a long line of code, but you'll see a kind of a pattern going on here. First and foremost, the most important thing I want you to realize when we display the final output to the user, in this case the final output is 13 degrees Fahrenheit is negative 11 degrees Celsius. That's what I mean by the final output. That last sentence where you're displaying the result of the calculation to the user. We have values coming from our variables. The original degrees Fahrenheit that I entered, the 13, is coming out of the temp variable. The negative 11, which we've calculated and rounded down, is still in the temp cells variable. So we're picking those values right out of those memory locations to display it to the user, which is the whole point of this program, right, is to convert a temperature and display the result to the user. Also, because we're forming a sentence with this, 13 degrees Fahrenheit is negative 11 degrees Celsius. We do also have to hard code the English language. Fahrenheit is and the spaces. I've got to hard code the spaces. So these are what we would call string constants. We talked about the numeric constants in the calculation, the 5, the 9, the 32, but you can also have string constants. A string is a string of characters all contained in quotation marks. So these are string constants. Again, not variables. We've hard-coded these values into the program. The word Celsius here is the word Celsius. It's not going to change. So, this line of output is really a mixture of variable values, values that are coming directly from our variables, and constants, such as these string constants. Now, you may have noticed that I was able to put little degree symbols in the output, and that can be accomplished by this. This is something that we'll talk about later, but if you're curious as to how I did that, because that's not a character on the keyboard, you can create special characters that are not on the keyboard by using text.getCharacter, and then you have to provide a little, like a code. And I happen to know this code in advance, that 176 would give me the degree symbol. So we'll do more of this later on, but that's how I did that. Now this whole thing here that we're doing, constructing that last line of output piece by piece, we have a variable value, a character predefined character constant, which I'll call for the degree symbol. Then we have a string constant, and then we have another variable value, then another character constant. You know, we're like piecing this all together, you know, one piece at a time, and joining it all together with the plus signs. This is called concatenation, this technique. It's a very common thing to want to do, is to build this output statement piece by piece, like kind of fastening it all together or joining it all together with the plus signs. These plus signs here are not plus signs like in a mathematical sense, as in we're adding values together. We're stringing values together. We're connecting them or joining them, kind of like beads on a necklace. So that is called concatenation, and that's another term that I would like you to know.